let's look at a nonlinear relationship. If we look at pressure versus volume, this is what's known as Boyle's law. And what it says is that if we increase the volume, the pressure goes down, or if we decrease the volume, the pressure goes up. So there's an inverse relationship. Now when I plot this, I'm going to get a 1 over x function. So I'm going to make a new data table that's going to have 1 over x, or in this case 1 over volume, as my independent variable, and then my dependent variable is going to stay the same. So what I'm going to do is do equals 1 divided by, and then I'm just going to pick the value that I want. So this is a3, and it's going to take 1 over that. Now what I could do is just drag all of these down, and it will repeat that function. Here you can see that it's 1 over a4, 1 over a5, and so on and so forth. So I could say that this is 1 over v. Now it has units of inverse volume, but let's not worry about that. And then we're going to put our pressure here. And I'm going to take the same values. So I'm just going to copy paste. The reason why I'm doing that is because Google wants the independent variable on the left and the dependent variable on the right. So it's just easier to do a new data table. Okay, now what I'm going to do is insert a scatter plot. So, okay, it's suggesting that I already have a scatter plot, which is great. And before I hit insert, I'm going to go to customization. I'll call this linearized p versus 1 over v. Then I'm going to go all the way down. Well, first, let's label the axes horizontal. I'm just going to say 1 over v. And then vertical, left vertical, I'm just going to call it pressure. Normally I would put units on this, but in this case, when you linearize it, it's not really as relevant. Okay, so now let's go down to the very bottom and trend line. So I can fit this to a linear function now because it is linear, so it looks great. I'm going to show my r squared value, and it equals 1, so that's beautiful. And then what I want to do is show the equation. I don't really need to because this is kind of a meaningless equation, but what I have is a nice plot here, and my r squared value is going to be my check in a way to see if it's a good fit. Google has a very limited set of fits. It's not a professional program in that if you go buy a nice graphing program, they'll have better fits. So it's good to linearize it because then you can check to see how nice your linear function fits. And so what we did is we took our pressure versus volume, we changed it to a new data set where we have pressure versus 1 over volume, and then we plotted that and checked the plot or check the fit to see if it looked linear, and it does. So I would say this is great.